Hey, this is Pooja and welcome back to my YouTube channel Maths with Pooja. Students, today we are going to discuss about trigonometric ratios. But before this, we discuss about trigonometry. What is trigonometry? Trigonometry is the branch of mathematics which deals with the angles and their application in their calculation. So, there are 6 main functions which are used in trigonometry, which are sine, cos, abbreviations used as sine, cos, tan, cot, secant and cosecant. As these 6 functions are used in trigonometrics, which used in trigonometric for their calculations with respect to angle. So today we are going to find the trigonometric ratios with the help of a right angle triangle. With the help of a right angle triangle, that means here we consider a triangle ABC right angled at B. And we have to find all the trigonometric ratios with respect to angle C. As with respect to angle C and angle B is 90 degree, so BC becomes base and AB is perpendicular, as also AC becomes hypotenuse. Now we discuss trigonometric ratios with respect to angle C. So here sin C becomes, sin C is nothing but sin C becomes perpendicular by hypotenuse. Perpendicular, that means AB, hypotenuse that means AC. This is the trigonometric ratio sin C with respect to angle C. Now we have to find cos C. Cos C is base by hypotenuse. Base is BC and hypotenuse is AC. Now we have to find trigonometric ratios tangent C, which is perpendicular by base. Perpendicular here is AB and base is BC. Now we have to find cot C. Cot C is nothing but base by base by perpendicular, base BC perpendicular AB. Now secant C is nothing but hypotenuse divided by base. Hypotenuse is AC and base is BC. Now we have to find cosecant of C. Cosecant of C is hypotenuse divided by perpendicular, and here hypotenuse is AC and perpendicular is AB. Now we find all the trigonometric ratios with the help of a right angle triangle in terms of perpendicular, base and hypotenuse of a triangle with respect to angle C, where perpendicular is opposite to angle C and base is nothing but base is adjacent to the angle C. Now all the trigonometric ratios, 6 ratios, we can calculate further trigonometric numericals with this help. Now here we can see that sin C is nothing but reciprocal of cosecant C. Here cos C is reciprocal of secant C and tangent C is reciprocal of cotangent C. So we can write as sin C is reciprocal of cosecant C. Here cos C is reciprocal of secant C and tangent C is reciprocal of cotangent C. Reciprocal, that means 1 by cot C. Now we can write cot C is nothing but reciprocal of tangent C. So we can also write cot C is equals to 1 by tangent C. Here secant C is reciprocal of cos C. That means we can write secant C is equals to 1 by cos C. And cosecant C is reciprocal of 1 by sin C. Here we can see that sin C is reciprocal of cosecant C and cos C is reciprocal of second last, that means secant C, and tangent C is reciprocal of third last, that means cot C. That means we can conclude that all the trigonometric ratios, when we remember all the trigonometric functions in this sequence where sin c first come, cos c, tan c, cot c, secant c, cosecant c, then there is no confusion regarding the reciprocal of their functions. So here one thing we can notice that tangent c and cotangent c. Tangent c and cotangent c are nothing, but we can also write these two functions as like this, where tangent c and cotangent c are also write as tangent c is equal to, we can write sin c divided by cos c. Why? We can also prove this. Sin c is AB, where AB is perpendicular, divided by AC, where AC is hypotenuse. Divide by, as also we know that equal comes here. Now, cos C is BC divided by AC, where BC is nothing but base and AC is nothing, but we also know that AC is hypotenuse, as we can see in this figure. Now, we can solve this as AB divided by AC multiply AC divided by BC. As AC cancel out AC, here AB divided by BC. That means tangent C is equals to AB divided by BC. So we can also say that tangent C is nothing but tangent C is the ratio of sine of angle C with the cos of angle C. Now, we can also say that cot C is reciprocal of tangent C. So, we can also write cotangent C. We can also write cotangent C is equal to reciprocal of tangent C. That means we can also solve these. Cot C is equals to 1 by tangent C. As we already proved, tangent C is sin C divided by cos C. As we know that tangent C is the ratio of angle of sin C with cos C. Now we can write cot C is equals to 1 by tan C, because these are reciprocal to each other. Now cot C is equals to 1 by tangent C. We can replace tangent C by sin C divided by cos C. So we can write sin C divided by cos C. As we solve these two terms, we get cos C becomes numerator and sin C denominator. So we can conclude these two terms are also reciprocate of ratio of the angle of the sine and cos with respect to this angle C. So these are the 6 terms, basically functions used in trigonometry, and these are the trigonometric ratios which are further used in our trigonometric numericals, which are discussed in further lectures. So thank you so much for watching me. If you like this video, then please share, subscribe and comment on my channel. Thank you so much.